All right, buckle up, everybody, because today we're taking a deep dive into some seriously mind-bending stuff, emergent properties.
Yeah, we're talking about how simple things, like, basic building blocks can somehow combine and create something way more complex, something totally new.
You know, it's kind of like when you're baking a cake, right? You've got your ingredients, your flour and sugar, eggs, pretty basic stuff on their own. But when you mix them all up together, just right, bam, delicious fluffy cake. That cake, my friend, is an emergent property.
Okay, so now I'm hungry, but yeah, the analogy works. So we're going to be exploring this idea of how something like a tornado comes from simple dust particles, or even how consciousness, our thoughts and feelings, arise from all those neurons firing in our brains. It's pretty wild stuff, right? And our guidebook for this journey is the Stanford Encyclopedia of Philosophy's entry on emergent properties, if I'm not mistaken.
You got it. It's a real deep dive into this fascinating kind of push and pull between two big ideas, dependence and autonomy, which are kind of at the heart of what emergence is all about. Dependence and autonomy. Huh. So two ideas that seem like totally opposite. Can you break those down a little bit further for me? Like, what do they actually mean in this context?
Sure, sure. So let's think about that cake again. The cake wouldn't exist without those ingredients, right? So in a way, it's dependent on the aerotar. Philosophers actually have a fancy word for this, supervenience. It means if you change those ingredients, like if you swapped out the sugar for salt, well, you're going to get a very different result.
Yeah, definitely not the same cake. But I mean, on the other hand, you can't fully explain the taste, the texture, the overall experience of eating that cake just by analyzing the flour, the sugar, the eggs separately, right? It's like more than just the sum of its parts, wouldn't you say?
You hit the nail on the head. That's where autonomy comes in. See, emergent properties, they have their own unique characteristics, their own behaviors that go beyond what you'd expect just from looking at the individual components. Philosophers call this non-aggregativity, which basically means the whole is greater than the sum of its parts.
Okay, okay, the cake analogy is really helping me grasp these concepts, I gotta say.
Yeah.
But now, the Stanford Encyclopedia gets a little bit more, technical when talking about dependence and autonomy. They start throwing around all these different types of dependence and autonomy, like modal, functional, nomological, causal, and I gotta admit, it starts to feel a bit overwhelming.
Yeah, it can get a little jargony in there, for sure.
So can we unpack those nuances a bit? Like, what are the different flavors of dependence and autonomy, and how do they all fit together?
Absolutely, let's do it. So they dive into these ideas like modal dependence, functional dependence, nomological, and causal dependence. All these terms, they might sound kind of intimidating, but really they're just describing different ways in which the emergent property relies on those base components. For example, causal dependence is just a fancy way of saying that the base properties actually cause the emergent property to exist. So, like, no swirling dust particles, no tornado.
Ah, okay, so it's like different shades of dependence, each with its own, specific meaning. What about on the autonomy side? Are there also different nuances there?
For sure. So, besides non aggregativity, the entry talks about multiple realizability and distinctive efficacy. Now, multiple realizability is this really cool idea that the same emergent property could arise from different underlying components. Like, for example, consciousness, right? Maybe it could theoretically emerge from, say, a silicon based brain, not just a carbon based one like ours.
Whoa, okay, that's a mind-blowing thought right there.
Hmm.
And then what about distinctive efficacy? Does that basically mean that emergent properties can have their own, unique effects on the world, that they can kind of do their own thing?
Precisely. Emergent properties, they can influence and interact with their environment in ways that those individual components just can't on their own.
Hmm.
Think about think about a flock of birds moving in perfect synchronization, right? No single bird is like calling the shots, dictating the flock's movement. It all arises from these complex interactions between all of them. And that synchronized movement, which is an emergent property, it then influences how the flock avoids predators or finds food.
Oh, yeah, that's a great example. You can't explain how that whole flock behaves just by studying a single bird in isolation.
Mhm.
All right, so we've laid out the basic ideas of dependence and autonomy with all their different philosophical flavors, so to speak. But I know the real debate, it heats up when we start talking about how much autonomy an emergent property actually has. And that leads us to the big philosophical divide, right? Weak versus strong emergence.
You got it. And this is where things get really, really interesting. Yeah, so think of it kind of like a spectrum, right? On one end, you've got weak emergence. Weak emergence says, hey, new stuff, it emerges, it pops up, but it's still, ultimately explainable by the laws that govern those underlying components.
Okay, so with weak emergence, it's kind of like saying, all right, the cake is delicious because of, the specific chemical interactions happening between all those ingredients. And those interactions, they're all following the laws of physics and chemistry, right? No need to like invent some new laws to explain why the cake tastes so good. It's just complex interactions, but based on those existing laws.
Exactly, yeah. It's all about how these complex systems, they can behave in ways that we might not expect, even if those individual parts, they're following, relatively simple rules. And this view, it fits pretty nicely with what philosophers call physicalism. This idea that basically everything in the universe, it all boils down to physical stuff and physical laws.
Makes sense. But then we move along that spectrum, right? And we get to strong emergence.
Yeah.
And that's where things get a little more, well, a little more radical, right?
Oh, yeah, for sure. Strong emergence, it comes in and says, hold on a second. Some of these emergent properties, they're so fundamentally new, so different, that you can't just explain them away by the laws governing their parts. It's like saying the cake's deliciousness is a totally new fundamental property, not just a complex result of those ingredients interacting.
Okay, so it's almost like strong emergence is saying, hold up, physics, chemistry, they're not the whole story. There's something more to the cake or, to the universe that we can currently explain with our current understanding. I can see how that would, ruffle some feathers in the scientific community.
Definitely, definitely. This is where the philosophical debate gets really heated. Strong arguments on both sides, For weak emergence, a big plus is, well, it keeps things nice and simple. No need to like invent new laws or principles.
Right, keeps things tidy,
Yeah.
like a well-organized, pantry. But how does weak emergence deal with those, like, seemingly, magical properties that pop up, the things that make you go, whoa, how did that happen?
Well, it's like this, right? One worry some folks have is this idea of something being overdetermined. Imagine a car crash, right? And it's caused by both a drunk driver and faulty brakes. So you've got two separate causes for the same event. And some people, they see this as a problem with strong emergence. Like, does it mean everything has two causes now? One physical and one emergent, which seems kind of messy, right?
Ah, I see. So weak emergence avoids that whole double causation thing by saying, look, it's all ultimately rooted in those basic physical laws. Okay, that makes sense. But what about the arguments for strong emergence? What makes it so appealing to some philosophers? Why go down that, more radical path?
Well, strong emergence, it really shines when you try to tackle those aspects of reality that they seem to defy those simple physical explanations. And the prime example here is consciousness.
Yeah, consciousness, of course. The classic mind-body problem. Can you really explain, like, the feeling of the sun on your skin, the taste of chocolate, or the joy of listening to music, just by talking about, neurons firing in the brain? It feels like there's this huge gap between the physical stuff and the actual experience, the subjective experience.
Yeah, it's the million-dollar question, right? And that's where strong emergence comes in and offers this really compelling alternative. It's saying that consciousness, it's not just some, complex interaction of neurons. It's a fundamentally new property, something that emerges from that complexity, but goes beyond it.
And the Stanford Encyclopedia entry, it digs into some specific aspects of consciousness that really, they highlight this challenge for purely physical explanations. Right?
Exactly. Yeah. They talk about awareness, unity, even free will. For instance, think about qualia for a second. Qualia, it's that subjective feel of an experience like the redness of red. How do you get that specific feeling, that redness, just from neurons firing? It's not like a neuron itself can be red, right?
It feels like there's this leap, this fundamental difference between that physical process of neurons firing and the actual subjective experience of seeing red. So awareness, that's one sticking point for sure. What about this idea of unity? What do they mean by that?
Well, think about it. Right now, you're experiencing all sorts of stuff. Sights, sounds, thoughts, feelings, all happening at once. But they all come together as this unified you, this single experience. So how do all those diverse signals, all those things being processed in different parts of the brain, how do they create that single coherent experience? That's another puzzle that strong emergence might help us solve.
It's like the brain is this like giant orchestra, but we haven't figured out who the conductor is. Who's bringing all those instruments together to make this harmonious whole? And then, of course, there's the question of free will, which always seems to throw a wrench into things. If everything is just, physical processes happening, do we really have control over our choices? Or are we just, along for the ride?
Yeah, that's the age-old debate, right? And strong emergence, it might suggest that free will, it's this genuinely new property, something that arises from, well, from the brain's complexity, that it allows us to make choices that aren't, simply predetermined by physics. It's a fascinating concept to explore, for sure.
Absolutely. So we've got awareness, unity, free will,
Yeah.
all kind of pointing towards the possibility that strong emergence might be at play in the mind. But is consciousness the only place where we might see this, this radical kind of emergence? Or are there other, other corners of the universe where it could be lurking? Well, we've been really deep in the weeds of consciousness here, which seems like, prime territory for this whole strong emergence thing.
Yeah.
But I mean, does this concept have implications beyond the mind? Are there other scientific mysteries out there? Other places where strong emergence might give us a fresh perspective.
Absolutely, yeah. In fact, some physicists, they believe that the really bizarre world of quantum mechanics, it might actually hold clues to strong emergence happening outside the realm of consciousness.
Oh, wow. Quantum mechanics.
Yeah.
That always makes my head spin a little bit, to be honest. So what's the connection to strong emergence there? What are they seeing?
Well, one of the most puzzling phenomena in quantum mechanics, it's got to be entanglement, right? You probably heard of it. That spooky action at a distance that Einstein was always talking about. It's where two particles, they get linked up somehow, and whatever happens to one, it instantly affects the other, even if they're like miles apart.
Yeah, entanglement, it definitely sounds spooky. And it doesn't really make sense, with our everyday understanding of cause and effect.
Yeah.
So where does strong emergence fit into all of this?
So some physicists, they're proposing that entanglement could actually be a sign of strong emergence, like happening at the most fundamental level of reality. It might suggest that there are, these deeper, more fundamental principles that are like governing how these entangled particles behave, principles that, well, that go beyond what we currently understand about physics.
So it's almost like there's this hidden layer of reality, right? It's like this cosmic puppeteer, orchestrating this whole dance of particles. And strong emergence, it could be the key to understanding those hidden rules.
Yeah, that's one way I think about it. And it's not just limited to quantum mechanics either. Some philosophers of chemistry, they even argue that molecular structure, like how atoms are arranged in a molecule, that could be a form of strong emergence too. They point to isomers as evidence for this.
Isomers. Remind me what those are again?
Right, so isomers, they're molecules that have all the same atoms, but those atoms are arranged differently. And that difference in arrangement, it leads to totally different properties. Like, think about graphite and diamond, right? Both made of pure carbon, but one is, soft and dark, the other one's super hard and sparkly. It all comes down to how those atoms are structured.
Oh, yeah, of course. Graphite and diamond, that's a classic example. So these philosophers, they're basically saying that the arrangement itself, the structure, it's an emergent property with its own, its own unique powers, not just a simple consequence of the individual atoms.
Exactly. It's like, you can rearrange the same pieces of furniture in a room and give it a totally different vibe.
Yeah, that's a great analogy. So if strong emergence is, potentially at work in chemistry and physics, maybe even in the very fabric of space-time, well, it makes you wonder, right? Could there be other areas of science where we're kind of missing the forest for the trees, where we're so focused on those individual components that we're not seeing the bigger picture, the emergent properties that arise from them?
That's a great question. And it's one that, scientists and philosophers are going to be grappling with for, well, probably for a long time to come.
Wow, this has been a wild ride, to say the least. We started with a simple idea of baking a cake and ended up questioning the very nature of reality itself. I got to say, this whole concept of strong emergence, it's both fascinating and a bit unsettling, It makes you wonder, are we just these incredibly complex machines running on the laws of physics, or is there something more to the story? Is there something else going on?
Yeah, and that's the beauty of philosophy and science, right? We're
Yeah.
always pushing those boundaries, always asking these big questions. And the more we learn, the more we realize how much more there is out there to discover.
I'm definitely left with a lot more questions than answers after this deep dive, but I think that's the sign of a truly enriching exploration, right? It sparks that curiosity, makes you want to keep learning, keep searching for those aha
Yeah.
moments that, that expand our understanding of the universe and our place in it. So to everyone listening out there, I encourage you, keep questioning, keep exploring, and who knows what incredible emergent properties you might uncover along the way.